All right, so we're going to have a guest teacher go over the homework for us. Here's your black pen, and there's your red pen. Okay, now all that intermediate stuff here you don't need. You just need to do this part and from here over. Okay. Yeah, the equality statement you need. Okay.
All right, the problem over.
If you can, try to explain it to the class as you go. That'd be great. If you can, I'll help you. Somebody else was asking a question. Was that Colton? No. You want to see it? Not right now. I just want to see who had done it and who had done a good job, and then I was going to offer the opportunity for them to do it for the class. Okay?
So I don't redo the problem?
Huh? You want to do all of this,
Okay.
your equality statement, and then this. Okay?
Okay.
If you don't turn it like that, I need to turn the camera for you. Go ahead. I'll adjust the camera to you, okay?
Okay.
How about that? All right. So this is the problem we did for assigned for homework. Okay, so let's see, we had 2.59 times 10 to the 20 atoms
Wake up, please.
of helium. That was our starting amount.
Robbie.
And put it over 1.
That's not you said. You make story?
Okay, William.
Can you breathe that?
Okay, Reese, Robbie, the problem, you need to write it down that we did yesterday. The problem was, here's what you need to write down. The problem was, write it down, please.
I got a question.
Yeah, give me 1 second. I will get them the problem, okay? Write this down. This is what she's solving for you here. You need to know what the problem is.
Can you read that?
Oh yeah, I can read it. Looks great.
Doing great.
Thanks, Skylar. I love you.
If you are given this many atoms of helium, that's the beginning of the question. If you're given 2.59 times 10 to the 20 atoms of helium, yes.
That's why I got a question on the 10 to 20. I could have sworn it was always 10 to 23.
Nope.
How did it change?
Well, this is 10 to 23 here. All right, but let me get back to that in a minute. Hold on. The problem for the 3 people who are absent is if you are given 2.59 times 10 to the 20th atoms of helium, how many moles is that? How many moles is that? If you are given 2.59 times 10 to the 20th atoms of helium, how many moles is that? That was the problem. Well, she hasn't finished yet. She's still working here, okay? Yes.
Why would you have to write that right there?
The equality statement?
Yes.
Because you have to permit it. Because in my years of teaching, I found that students have a lot of trouble with figuring out how to build this conversion unit up here. Okay? This is what you build it from. I want you to get used to that process, and trust me, when you go on and have to do more conversions later in other classes and in college, this is going to be helpful to you. Okay? Well, you don't have to trust me. You just have to do it. Okay? All right. We need an equal sign right here in front of that. And you got to cancel your units and species. So please do that in red pen.
Okay.
Cancel units and species. Okay? So because we have atoms on the top, this is a multiplication problem. We're multiplying. This is multiplication and division. We're multiplying 2 fractions. And because we have atoms on the top, atoms on the bottom, we can cancel them. Because we have heliums on the top and heliums on the bottom, we can cancel them. Just like x's and y's in algebra. Okay? You work the same process. Okay? So, you have to have the atom inventory. I'm sorry. You have to have the equality statement. Okay? In order to write the conversion unit. And the reason I want you to do that, James, is because if you write this down and choose the side of this equality statement that matches the starting amount over here, and you put that on the bottom. So the side here that has atoms of helium, that goes on the bottom here. Okay? You will be able to set up your conversion units properly. You need to understand where it comes from and why we do it that way. So there are lots of conversion units in this unit of instruction. This is just the first one. If you do equality statements every time, you should be able to set up these conversions properly. Okay? Okay. Any other questions? So that's the homework and the solution. And for those of you who did it at home and did it right, congratulations, good for you. I expect you to make A's on the test. That's great.
What if those who tried and got it wrong?
What?
When's the test?
I haven't decided yet.
I was listening, but I still didn't figure out why why it changes slightly different. Does it change with different elements?
No, the 2.59 times 10 to the 20th, I gave to you in the problem. 10 to the 23 only applies to this all the time. Okay? Any other time, I would have to tell you how many there are. This is a fixed number. It's a value that's well known. Okay?
Okay, so so basically you'll say what it said up there, except it'll be like if there are 47.5 or whatever moles.
Butane.
Then where does it tell you it's 10 to 20 in that equation?
On the one I have on the board here? Okay. The one on the board here says if there are 47.5 moles of butane. Well, in that case, we're not starting with the number of particles. Atoms are one of the particles we can talk about here. We're starting with how many moles. So, in that case, this conversion unit will be reversed. The moles will be on the bottom, and the molecules will be on the top in that particular case. Okay? Let's look at that. All right.
What side does our name go in on our notebook?
In your lab notebook, you don't have to put your name on a new page. In a lab notebook, you put dates in the upper left, page numbers in the upper right. Okay. All right. Let's do this problem. Everybody, write this problem down I have up here, and we'll do that one too. And so that one's set up differently. We did one of these in class like this yesterday. Okay, so here's the problem. So we're going from molecules to moles. We're going from molecules to moles. Molecules is one of those particles I said. Molecules is one of the particles we talked about yesterday. Particles can be atoms, molecules, monoatomic ions, polyatomic ions, electrons, protons, neutrons, and Dorman High School students. Any kind of particle. Huh? Alright? So what we have here is we're trying to get from moles to some kind of particle. From moles to some kind of particle. Anytime you're going from moles to some kind of particle, you're going to use the same equality statement. We're just going to change what kind of particle and species we're using. Okay? This problem is talking about particles that are molecules. This problem is talking about particles that are atoms. Okay? So the equality statement we're going to need for this is 6.02 times 10 to the 23rd. The particles in this case are molecules. So we're going to put molecules here. The species is butane. Now we need to figure out what butane is. Let me come back to that in a second, okay? And then on the other side we're going to have moles, like up here, or 1 mole. That's the relationship, 1 mole of butane. I'm going to help you figure out what butane is. Now, in a couple of units ago, we were writing some formulas for organic compounds. And you should know what that BUT tells you about the formula for this compound? What can that BUT prefix tell you about that compound? Not 2, that's F. 4 what? Carbons, okay? So we got 4 carbons, and what does the ANE tell you about those carbons? Huh? What is the ANE suffix? The prefix is but, that means 4 carbons. What does the ANE suffix tell you? No, it's not a gas. What? Well, there will be hydrogens attached. But what the ANE tells you is there are nothing but single bonds between the carbons. Okay? Nothing but single bonds between the carbons. I think that was unit 3. Okay? And then each carbon has to have how many bonds total? 4 bonds on every carbon. So then what you're going to do is finish putting hydrogens on there, which we called in this class a terminator, remember? To get 4 bonds. So how many hydrogens am I going to put on this carbon here? 3 more. 3 hydrogens. How many on this one? 2. How many on this one? 2. How many on this one? 3. Does everybody understand what we're doing? You remember that? Okay. So now we can write a formula to plug in this equality statement here. How many carbons do we have? So the molecular formula is C4. What's the rest of it? How many hydrogens do we have? 10. So C4H10. That's the formula. C4H10. No, that's methane. CH4 is methane. This is a different formula. Okay? All right. So we have the equality statement. So anytime we're going from particles to moles, or from moles to particles, in this case we're going from moles to particles, we're going to be using this same equality, but we might need to change what the particle is, and we definitely have to change what the species is. Okay? But the 6.02 times 10 to the 23rd is always constant for going from some kind of particle to moles. And the 1 mole on this side is always constant. Okay? What now?
I don't understand what you just did.
What we did here.
Burning something in the mold?
No, we're not burning anything this time. We're just trying to find out how many moles there are in this, how many particles, how many molecules there are in that many moles. We haven't finished the problem yet. We've only started getting ready to do the problem.
So for this one, you use the
Equality statement?
The molecular form to find it?
Yeah, we wrote out this complete structural formula just to find this molecular formula. That's all we're trying to do.
So how do you know when you use it for this stuff?
Well, what I'm saying is if I give you the name butane, we have a lot of names for a lot of different chemicals. You need to know how to write the formula from the name. We did that in units 3 and 4. Okay? We did all that in 3 and 4. We've been using them since. Okay. All right.
But it just, I don't know, I don't understand. I don't understand what you're saying. Like you talking, just not gonna help me do it.
Yeah, I ain't get any.
Are you asking me a question?
Yes.
What's the question?
The pink is not butane instead of having
Could you write the name instead of the formula? Yeah, I guess you could in this case. You wouldn't be able to do it for other things, but you can in this case. Okay?